In this lesson we're going to continue looking at sequences, and we're going to look at how we can find the general rule when we're given a linear sequence. Well, the first thing we need to do is know what a linear sequence is, and a linear sequence is one that goes up by the same amount every time. Okay, so a couple of examples of linear sequences in a moment, and they all have the form un equals an plus b. So it's something times n plus another number. So a couple of examples of linear sequences then. We have un equals 3n plus 2. And then for that, for our values of n, if we write n across the top here, we could have 1, 2, 3, 4, and 5. Let's look at the first 5. When n is 1, we get 3 times 1 plus 2 is 5. When n is 2, we get 3 times 2 plus 2 is 8. And then we get 11, and then 14, and then 17. And what you should notice with these numbers is that the difference each time between subsequent terms is 3. And that's really important, because if you look back at our general term, we have that number there, 3, multiplying the n. Let's look at the next one, see if we get a similar result. This time we have minus 2n plus 17. So when n is 1, it's minus 2 plus 17. That gives us 15. When n is 2, it's minus 4 plus 17. That gives us 13. When n is 3, it's minus 6 plus 17 gives us 11. Then we get 9, and then we get 7. And once again, if we look at the differences, this time it's going down by 2, down by 2, down by 2, and down by 2. And once again, this time it is decreasing by 2, so we have negative 2 is our difference, and negative 2 is what's multiplying the n. If we look at this in a bit more generality, then we can look at what we get when we have un equals an plus b. So we had our values for n across the top. I'll just write those in again because we've lost them off the top of the board. 1, 2, 3, 4, and 5. When n is 1, we get a plus b. When n is 2, we get 2a plus b, because we have a times 2 plus b. When n is 3, we have 3a plus b. When n is 4, we have 4a plus b. And when n is 5, just going to move that one along a little bit, we have 5a plus b. And what you should notice this time when we take the difference is 2a plus b minus a plus b. Well, the b's cancel and we end up with 2a minus a, which leaves us with just a. 3a plus b minus 2a plus b again leaves us with just a. 4a plus b minus 3a plus b gives us an a, and 5a plus b minus 4a plus b gives us just an a. And if we were to carry on, it would carry on doing that. And again, we notice that that a is what's multiplying n, and that works for any linear sequence. So if you take the difference between the terms of the sequence, we find the number that multiplies the n in the general term. Then we can use the first term once we know a, and if we know the first term, we can use a plus b to find that bit. So once again, if we look back at these two up here, once we'd worked out 3 was a, we know that 3 plus b equals 5, so b must be 2. Once we've worked out minus 2, we know that minus 2 plus b must be 15, so b must be 17. So let's have a look at a couple of examples without the rule given to us to start with. So here we have the sequence 4, 11, 18, 25, and 32. The first thing we do is we find the common differences, and it's 7, 7, 7, and 7. So the first difference in this case, the difference between each of the terms is 7. From our general rule then, we know that un is equal to 7n plus b. But we also know that b, we get 4 from that part. So when n is equal to 1, we get 7 plus b, and we know that is equal to 4 when n is equal to 1, and that gives us b, which is b is equal to minus 3, which gives us our general rule un is equal to 7n minus 3. Let's take a look at one more example. This time we have a decreasing sequence. Again, the first thing we do is find the differences. Minus 4, minus 4, minus 4, minus 4 every time. So we have un is equal to minus 4n plus b. Again, we don't know what b is yet. But when n is equal to 1, we get minus 4 plus b is equal to 41, and that gives us, when we solve the equation, b equals 45, which gives us un is equal to minus 4n plus 45, or sometimes we might write that as 45 minus 4n. So that's how we use the general rule to find the general term for any linear sequence, and we will see a very similar method for finding general terms for quadratic sequences in the next video.